This last little bit of 6.5 is really just a recap. It's a review of everything that we've gone over with factoring. So it's these 5 steps are what you use to factor many polynomials, and you just keep doing them and doing them and doing them over and over and over until the polynomial is completely factored. Okay, so first thing you do is you look for a GCF. Never forget that. If you have a greatest common factor, always take it out first and always look for it, right? And especially if your leading coefficient is negative, you really want to look for it because we do not like leading coefficients to be negative if we can help it. Okay? All right, so then if it's a binomial, then binomials have very special properties. They're either going to be sum of cubes, difference of cubes, which again, you don't have to memorize that formula, or difference of squares or sum of squares, which is prime. So if you see only 2 terms, see if you can get it to be one of those. Of course, this is assuming that when you took out the GCF that nothing major happened, right? All right, so then for a trinomial, if A is not 1, or excuse me, if A is 1, that's easier. You're just looking for 2 numbers whose product is C, whose sum is B. Very simple. If A is not 1, then you have to either use trial and error or grouping. Grouping's probably the easier one of the two. And then for an expression with 4 terms automatically you know is grouping. Just done. If you see 4 terms, grouping. Okay, so let's look here. These ones are binomial, so they're probably going to be kind of special. Let's see if we can make it work. All right, so let's see. But the first thing I want to do is look for a GCF on this one. So it's 27x cubed minus 12y cubed. Oh, 12xy cubed. xy squared. Sorry, losing my brain. All right, so xy squared, there we go. So we could take out an x from both things, and we could take out a 3, right? Because 3 goes into 27, 3 goes into 12. That'll leave you 9x squared minus 4y squared. All right, I took out a GCF and now I've got this, and this is a binomial and it's a difference of squares. So that's going to be equal to 3x, and I'm going to do double parentheses. And the difference of squares, remember, is the easiest factoring you can have. It breaks up perfectly evenly into the square root of 9, which is 3x and 3x, and then the square root of 6, or excuse me, the square root of 4, which is 2 and 2. So it's 3x minus 2y, 3x plus 2y. They're binomial conjugates of each other. And there you go. Oops, let me line them with the equal sign. All right, now what about B? B would be, it looks like it's a sum of squares, right? Is there anything that can come out of it? No, there isn't. So this is prime. This is the sum of squares with no GCF. Right, so there was no greatest common factor to take out. Cool. Let me give you another example in here. I know this is going to be a little strange, but let me throw in, since that was so simple, let me throw in 5x squared minus 90x. So I'll get some students that'll look at something like that and they'll be like, oh, it's not a difference of squares because of the x, right? So what you want to look at is it's got 5x. You can take that out. That leaves you x squared minus 18, right? Because, wait, did I do that wrong? Yes, I did. It's not x squared. I'm losing my brain. All right, so it's x, right? Because you had 2 x's right there. You took 1 out, right? That leaves you 1x left over. So it's 5x squared minus 18. Done, right? There's nothing else to do. It's a GCF factoring, right? So I just threw that one in there for the fun of it. Good times. Now let me throw in another one. Let me make one up. Hold on. I'll be right back. There we go. I got one. Now I know you're thinking, Alana, what are you doing to us? Yes, I know it looks hard, but do you notice how 468, 240, how much you want to bet 4 goes into all of them? Always look for those GCFs first, especially if you start seeing huge freaking numbers like that. That's a sign, right? There's a sign that maybe there's a GCF you can do. All right, so let's see if this works, because I did this in my head. So 4 times x squared would be 4x squared. 4 times 17 is 40 plus 28, so that's 68, so that's right. And then 6 times 4 is 24, so this is 240. So this is good. Equals, all right, that's 4 in front, and I'm going to do double parentheses. It's going to be x and x. Now I'm going to have a plus and a minus in order to get me the minus 60 that I need back here. So what things multiply to 60? 1 and 60, that won't work. 2 and 30, well that would be 28 for the middle. Or how about 20 and 3? There we go. So that's actually one where a was equal to 1. See the x squared? It was just plain x squared. So this was, once you take out a GCF on this one, it's actually a much simpler problem. All right, so let's do E. Now E, or sorry, it was the old C. It's currently my E because I just did this one. All right, so this one's got to have a GCF as well. I can see it from here. 5 goes into all of them. So if you have 30x squared, let's see, minus 25 xy plus 5y squared, then that's equal to 5 comes out of all of them. So that leaves you 6x squared minus 5xy, oopsie, plus y squared. Like that. Okay, so we're going to need two numbers that multiply to 6 but add up to negative 5. All right, hold on. All right, so what I'm saying is I noticed that it's not, if you look here, our leading coefficient is not 1. So I'm going to do a times c, which is, let me delete all this stuff. Okay, so I need it to add up to negative 5 in the middle, but I need it to be 6 times 1. 6 times 1, which is 6. So I'm going to need it to multiply to 6, but add up to negative 5. Right? Right. So that'd be negative 1, comma, negative 6, right? Because that won't even multiply. Well, that adds up to negative 7. Or it could be negative 2, comma, negative 3. There you go. It's negative 5. So this one actually isn't even that hard. Let me delete all this. So let's see here. I want this one. I'm going to break it up into 5 times, and I'm going to do that factoring by grouping thing where I'm going to break up that middle term. It was negative 5xy. I'm going to write it as minus 2xy minus 3xy. It's this part right here. Okay. Hold on. There we go. All right, so I'm going to make it minus 2 minus 3. So it's 6x squared, but instead of the minus 5 business, this part right here is going to get broken apart. Instead of writing minus 5, I'm going to write minus 2 minus 3. That part breaks up. Oh, I don't want to do it that way. It'll just be confusing. So write minus 2xy minus 3xy plus y squared. I'm breaking that middle one up into two parts, the two parts that I found right here that I highlighted in yellow. Now I can factor by grouping. I can say, well, let's see, that's 5 in front. We don't care about that part. Then you look at these first two terms. They both have a 2 and an x that can be taken out. So 2x, that leaves you 3x minus y, because y times 2x is 2xy. Minus, because I need this to turn into positive 3. Currently, if you look in the parentheses, it's positive 3. So even though it's a minus 3, I need to make it positive 3. So I'm going to subtract minus 3, and again, there's a y in both of those terms. And that leaves me x. Oh gosh, I'm losing my brain. It's not minus 3. This term doesn't have a 3 to give. What am I thinking? It has a y to give. So let's do minus y. And that leaves me 3x minus y. Reason being because minus y times a minus y would make a positive y squared. Now you can see that they have the same factor. They both have 3x minus y in them. So you can factor out a 3x minus y. That leaves you 2x minus y. Right there. 2x minus y. Okay. All right, so let's look it over again, make sure we understand. Okay. We took 6 times 1, which made 6, and we figured out what factors of that made negative 5 when you added them up. Right there, it's 2 and 3. And then we said, okay, so I'm going to take the minus 5 and we write it as minus 2x minus 3x. And the y's are still sitting there. So then we took these two terms right here and I'm going to underline them so you can see it. We broke them up into this part right here. So we said, okay, look at 6x squared minus 2xy. They both have 2x. So we factor out a 2x. That leaves you 3x minus y. And then we took the 2 in the back here, and they said they both have y's. And you could have done positive y, but the problem is then it wouldn't match. And you need the 2 to have the same parentheses down here in the step that I currently have highlighted. So you take out a minus y. That'll turn this to positive 3, which is what we want. And then a minus y away from positive y squared makes minus y. Then they both have 3x minus y's. That's right here. And that leaves you 2x in the front term minus y in the back term. And then you still have a 5 sitting there in front of the whole shebang. And you're done. Those are the hardest ones. The ones where a is not 1 are the trickiest. And again, you could do trial and error. That's the other method. And this particular problem is actually a pretty easy trial and error method. But I wanted to go over how to do grouping again one more time. There we go. I've got that work over there. I think I'm going to add in one more. We've got a little bit of time. Let me make one up. There we go. I'll use this one. All right, so let's see here. And again, this is really my new F, I suppose. And this is really D over here. Oops, there we go. F. This is I made up an F. There. It's not a good F, but you know, hey. Okay, so I'm going to look at it and notice right away, hopefully, that it has 4 terms to it. Okay, so what we're going to do is we're going to do factoring by grouping. You're going to group together these first 2 in your mind. Say, okay, they both have a 4x squared that you could take out. That'll leave you 5x, take away 2, right? Because 4 times 2 is 8. Now, you need 5x minus 2, and you're close. Look at this. You've got 5x plus 2. And I'm thinking, well, what would I take out of that? But you need the parentheses to match, remember? So if you take out a minus 1, that'll make this negative 5x turn into positive 5x. And it'll make this positive 2 turn into negative 2. Crafty, huh? So this is equal to 5x minus 2, because now they've got, oops, they're the same. 5x minus 2, and then 4x squared minus 1. Oh, but you're not done. Not by a long shot, because you have to do this back one right here. That's a difference of squares. Okay? So if that's the case, you need to keep going. You never stop until you're completely factored. Okay? So since we're not completely factored, we got to keep going. We're going to write equals 5x minus 2. Luckily for you, difference of squares is the easiest factoring you can do. So it's 2x minus 1, 2x plus 1, because they're perfect squares. And there's that answer right there. All right, so the moral of the story, 1, always do a GCF. Always, always, always. It can make problems that seem really impossible for numbers become actually quite simple. Right, if you do a GCF. And don't forget GCFs on these ones. People always do. I don't know why. But they're not even hard if you just remember to take out a GCF. Okay, so that's step 1. Step 2, if it's a binomial like these 2 were, or like this one was, right here, this was a binomial, but it ended up being even easier than a binomial, or like this one right here with the 4x squared, that's a binomial, then you have to do either sum of squares, difference of squares, sum of cubes, difference of cubes. Remember, sum of squares is prom, as long as there's no GCF. Right, so then if it's a trinomial like D was and like E was right here, then you're going to have to either do simple stuff like this one, end up being A is equal to 1. So you just found what 2 numbers multiplied to 60 but added up to 17. Done. This one was much trickier, so you had to figure out what multiplied times 6 times 1 and then added up to negative 5, and then you went from there. And then, so 3b is actually the hardest kind of factoring you can have. And again, I remember tackling that by, I recommend tackling that by grouping. And last but not least, if you see 4 terms, like I just made up this F1, that's factoring by grouping. All right, we are all done with factoring, at least for this, and we're going to start factoring to solve in the next section. So I'll see you then. Enjoy.